Hello and welcome back to the radio room. Still working on the FT101, but I kind of had a little bit of I don't know what the best way to put it is. Well, in the last video we tested the JFET that we were suspecting was the problem on why we didn't have proper ALC meter action, and we didn't have any output on single sideband. And I kind of changed my mind on that JFET. The reason why, and I've already put the old one back in here, and there's a reason why I decided to do that, because I don't think it's bad after all. So let me just let me kind of go through what I was thinking, because I got some more JFETs in. There's MPF 102s. Not sure if they were going to work. Was thinking they probably would. But I got out here and I started. The first thing that came through my mind was, okay, let's make sure that the new JFET plays right. And I put it onto my DMM in diode mode, and it tested fine. But then I got to thinking about the layout on the board. Now, if you'll remember, when I was going through all these data sheets last time, and determining which of the pins was the drain, which one was the source, which one was the gate, I went off a 2SK19Y, which is the successor JFET on these boards, so to speak, of the MK10. Thinking, okay, Yaesu back in the 70s or whatever couldn't get MK10s anymore, or they decided, I don't know why they changed it exactly, but I have a feeling it had to do with the fact they couldn't get the MK10s anymore. So they moved to the SK19Y. Now, I had the hardest time in the world trying to find out, or trying to find any data sheet for an MK10. I have yet to find one. It's particularly one that shows the pinouts. So I was going under the premise that, well, if they're putting a 2SK19Y in the same exact holes as an MK10, then it should have the same pinout, and that's what I tested it on. But when I came out here, in my mind, I was like, well, I took this thing out of here, and I kind of know where on the board things are going as far as where they're coming off of that JFET. And some didn't seem right. So I'd come out yesterday morning and was fully preparing to make a video on installing the new JFET, putting it in the radio, seeing if it works. But in my thinking of it, I was trying to figure out, well, how in the world does this work with the order that the pins are in? And I got some pictures here I'm going to show you here in just a moment. So let's take a look at what is in there. Here's our board. I do have the new, or the JFET put back in. It's that black blob right there. I've put it back in. Just a real quick overview of the JFET that we're working on. If we go over here to our schematic, and this is out of the service manual. Pretty much all the modulator units for just about all the models are the same. There's slight variations in difference. We have a PB 1184. The next iteration was a PB 1184A. And there's two different if you look right here, this says 2SK19Y. Let me go over to actually, let me just go over here. We'll have to come back to this page here in a minute, but I want to look at the actual schematic for the radio. Just let's see. Okay, so, and if you look at this schematic, they're calling it an MK10. They're both JFETs. They both have similar characteristics. But the MK10 is in the earlier models, it looks like, and then they had moved up to the 2SK19Y. Well, if you look right here, this is what they're talking about right here. This is the JFET. It's got gate, it's got drain, it's got source. If we go here, which is just a schematic of the board itself, we got gate, we got drain, we got source. Exact same setup. I mean, aside from maybe the lines are drawn slightly different directions, everything still connects the same. You still got your drain, you got, let's see, I've been looking at these schematics so much I'm going dizzy. Right here, this line right here, this is positive voltage that's going to the drain, that's powering it. We still have 14 right here that's going to ALC, goes to the ALC meter, and this is coming in from the ALC circuitry from the final amplifiers. And then of course we still got T110 right here, which is where we're feeding our audio into it. So we still have the same thing here, just this is turned sideways. So everything's pretty much the same. We still got our voltage right here going to our drain. We still have audio coming in, and this does not show well, it might be right there. I'm just looking at. So here's our ALC coming in right here. See, it's just coming in from the bottom instead of coming in from the top. So everything's pretty much the same there. So I was looking at, okay, 2SK19Y, MK10, same exact schematic. I can't find a data sheet for an MK10 to save my life. So I was going off the fact that they were pinned out the same. So I tested it in the last video, saying that we had a drain to gate leakage both directions, and you can't have that, it must be bad. But I found something else out, and this is what really came out and made me wonder what was going on here. Let me come back to the camera here. So here's just kind of a blown up version of what we were just looking at. We still got ALC input coming from pin 11. This is T110. This is where our audio is coming in. This is our first IF amplifier. So basically what's happening is that the carrier, depending on what sideband you're on, is off over here. The ring modulator's off over here. It injects the carrier. It also mixes in the audio coming off the audio board. It all gets amplified through T110. It's not so much of an amplifier so much as it increases power, as it takes it from increases the voltage, which feeds the gate. The output's over here, got a little blocking capacitor right there because this does have V+ on it, and this goes to the next stage into the mixer board. And of course source comes down here, and of course as this is opening and closing, it's sending a signal to the ALC meter, which is changing the reading on the meter. When this voltage drops to a low enough negative, it increases the amount of negative voltage on the gate, which really closes the FET down, which keeps it from conducting, which decreases its gain, and obviously you don't get as much output. That's how the ALC works. If this goes low enough, it brings this down. So, right, and I didn't put the mark here, but right here is a variable resistor. That's VR2. It's to set the ALC meter. So when you have no audio going in, the ALC meter on a 101 works, I guess you could say, almost backwards. from what you would be used to on looking at an ALC meter on, say, a modern rig. Normally on a modern rig with no audio input, if you look at the meter, the bar graph, however your meter works, it's sitting over here until you talk, and then it's on the voice peaks, it's coming up like this. And then when you stop talking, it goes back to the left. So on a 101, with 0 audio input, it's full deflection. As you talk, it comes down to a point about halfway. Once you get that halfway mark, if it has to go any further, that's when this is getting to about negative 1.5 volts, which is basically really reducing this, which reduces the output, reduces the drive, and keeps you from overdriving your radio. So just kind of a little tidbit there. When I first was playing with it, I was like, why does this thing need to be set to full deflection on the meter if I have no audio input? It works backwards. Okay, fine. But I was looking at this, and the source is going to that VR. Right there is that VR. Here's my FET. The drain's actually connected over here. It actually goes to this variable capacitor right there. And the gate circuitry is the hole in the middle. Well, that didn't make much sense. In fact, let me show you what I'm talking about here. Here's a little more exploded view, and you can probably, maybe even see the problem I was having. So here's our holes in that board. Right here. This is just like this board is sitting. I just kind of blew it up here. So the drain, let's go on TC6. That's that one right beside it I was pointing to. Here's VR2, the one at the top that I was showing you. Right here. And then gate comes over here and goes down to pin 11. Through a 100K resistor. So we got drain, gate, source. Well, if you look over here, here's the two SK19Y. That's the data sheet I was going off of for pinouts to test the MK10, which is drain, source, gate. Well, how in the heck, if it's drain, source, gate, can you have drain, source, gate when it's supposed to be gate, source? When I pulled this out, the legs were like this. So it should be drain, gate, source. The MPF 102 matches what I had seen on the two SK19Y. So I got to thinking, whoa, maybe the MK10 doesn't have the same pinouts. The legs are not the same, and they're not. If you look at it, now here's the square side here, and the square side normally faces that way on the board. And you can kind of see that here. So if I rotate this around like that, the source is on this side, the gate's in the middle, and the drain's on that side. Which is exactly what I need right here. So, I was thinking, well, if that's the case, then we've got a problem. If I put this in the same way, obviously it's not going to work. But there's another problem, the second problem. How does that change when I tested it? Because remember, I was going what I thought was drain to gate both ways with my meter, and I had conductivity. And I was like, well, that's not right. You can't have that. So it must be bad. But if you look right here, this is the way it's actually pinned out. Now these are sitting so they're in the same relation to each other. We got the flat side up. We got drain source gate on those. That one you can't have conductivity between the outside legs. But between the source and the drain, you can on a JFET. In fact, you'll have conductivity both ways no matter what. Unless it's turned off, which would be, in this case, a negative voltage to the gate. So I had pulled it out, and I've already put it back in there. So here's one of the new ones. Let me spread these legs out a little bit so you can see them. Hopefully y'all can see that. There's one of the new ones. This one right here I have set up so that it's in the same orientation. Let me think here a second. So I bent the leg. Now mind you, when this one's in, it's actually like that. In the old one would be face down compared to each other, because I got to get the drain on the same side in order to put it in the circuitry. But this one's set up more the way it would have to go in there if I were to use it in that. And if you'll notice, kind of got two legs crossed. Let's see if I can get this so you guys can really see it. See how I got the two legs crossed? I got a little bit of heat shrink in there because the other two legs would short out with each other. So let me show you what this wants to do. So here's our new one, which y'all can't even see. So let me just keep it up on the board here. Here's our new one. And I'm going to test this one just like you would test, like I tested the other ones. I'll get some leads on my multimeter here so I can clip it and not chase this thing around the desk, because that's what I'd end up doing. Trying to just use points on these, so I'm going to use some clips. See if I can get this in a spot where y'all can see it good as well. Can y'all see that? Nope, not really. We'll set it right there. Oh, maybe right here. Okay, y'all can read that. Okay, I got my clip leads. Nice clip leads. So, let's look at this one right here. This is what I'm testing. Drain, source, gate. So we're going to test this JFET. Correction, it is not a MOSFET. They do not work with interchangeably. So this is a JFET. It's an N-channel junction field effects transistor. So I'm going to go from the drain to the source. And apparently I got some... Okay, there. Had a bad connection here somewhere. Somewhere I have a bad connection. Okay, so you have conductivity. Now let me reverse those on the drain and the source. And I do have conductivity. I'm having something on bad contact here or something, but there you go. That's a little more stable now. Okay, so if I go in that case, and this, now remember I've got this one set up. Whoops, lost my little piece of heat shrink. Let me get this back in here. I got this one so it's pinned out the same way as these. They're in the same order, which is what I thought the other one was. So if I go drain. Now remember, the last time I tested these two right here. Well, let me show you one other thing real quick so I can give you a better comparison here. When I tested that transistor on the last video, I went from here to here. See, I got a reading there. In fact, that's a diode drop. That's a silicon diode drop. Because I thought I was going from the drain to the gate. I'm like, okay, well that's fine. I thought I was going from the drain to the gate. Okay. Well, that's fine one direction. You're supposed to have it one direction. But if I go drain to gate, nothing. That's the way it's supposed to work. So when I tested this one's just standing in for the one that I tested last time. I just got the pins in the same order. I thought I was going from drain to what I thought was the gate. And I got conductivity. In fact, okay. So there you go. And then I switched them and reversed them. And I still got conductivity. And I was like, well, it's bad. You can't have drain to gate both directions. Not to mention, it was a little low. So on a good one, I'm sorry. Let me go back to this one real quick. See, that was the pinout that it was in. So I thought because I was going from what I thought, going off of this pinout from the only thing I'd seen, I thought it was the same. I thought we had bad because I was going from outside side leg to outside leg, which should only work one direction. Even if you go to the source. What I thought was the source find my other lead here. So I got it that way. But I don't that way. Well, that one's actually right. That's what was throwing me off and confusing me, because I thought when I went to the two outside legs, I was going drain to gate. Okay, well, we got a drain to gate junction failure. So, but that's not the way it actually is. If you look right here, the MK10, and this is set up in the same way, is source. Let me flip it over. Source, gate, and drain. I might actually have those backwards. Okay, I did this, set this, but anyhow, they are switched around. So the gate's in the middle. So when I tested it, I did get the proper reading. I know this is kind of confusing. I'm kind of confusing myself too, because I should have just left the other one out and actually showed you on that one, but I was kind of getting ahead of myself and put it back in. Needless to say, I pulled out the modulator board from the 101E, the other 101E, or the other 101 that I'm working on, and looked at the two SK19Y to find out, well, if the board layout didn't change, and the board layout didn't change, how are they using a 2SK19Y in that configuration? Well, guess what? As soon as I pulled it out and looked in here, they had the legs crossed to make this pin out go where it needed to go. Needless to say, what I'm trying to get at is I don't think the MK10 is bad. Which brings us back to the same point in time of what problem do we have? We have the ALC meter like just pegging itself, no matter what you do to VR2. And we have no output really on single sideband. So we're kind of back to square one on that one. I know it's a little bit of a confusing video. I'm kind of, my brain is fried. I have looked at so many schematics, so many data sheets, trying to figure this out, all on the computer, and a lot of it is you're flipping back and forth between pages. Just to give you an example, trying to figure out where things are going. So there's the board one, shows you the pinouts. Here's the schematic for the radio. And say I'm looking at the output of the first IF amplifier. Where's it going? Okay, well, the signal's coming out here. Well, it ain't going there. That's positive voltage. Oh, here it is. DC blocking capacitor goes over to 12. Comes out of 12. Comes up here, and we got 13.5 volts there too. But blocked. So we come through here, and we go over here. Okay, 15. So here's the next IF amplifier in the mixer unit. Well, let me kind of zoom out here, and you can kind of see how fun this is to try and do stuff. I was also working on, well, where's the ALC go? Well, here it comes out, here it goes to 14, comes over, comes down, comes down, comes down, comes over. Let's see, I'm going to lose it. Comes down here to this switch. And then where's it go? Okay, so it goes to the page up here. Try to find that. Okay, so it goes over here, but I'm missing part of the switch right there. So I'm switching between pages. I'm trying to read between boards. My brain was fried last night trying to figure out where everything's going. But let me get to the point of what I'm thinking is the problem. Let me, let's see here. Trying to remember, I think it's page 13. Yes, page 13. So if you don't want to trace schematics all over the place, see if you can find an operational block diagram of the radio. Here is the 101, which is slightly different than the 101E, mostly in the way the ALC works. But I was trying to narrow down what could be the problem, because let's take what we know. For one, when I was doing some testing on the radio, it appeared that I had audio coming into it, going through it in AM, no problem. I was getting swing over to the max. I was running about, I think I was on 20 meters doing a test. Had carrier set at right around 25, and I was swinging close to 100 watts on peaks. Right where it's supposed to be. What else do we know? We can receive. We can receive AM. We can receive lower sideband. We can receive upper sideband. We can receive CW. Okay. So, on a lot of transceivers, components, sections, modules of the radio serve a dual purpose depending on whether you're receiving or you're transmitting. It uses the same components. Mostly. Not all of them. Some are just transmit, some are just receive. So I got to narrow down what do I know is working, what's not working, and then find out what in that chain would cause that. So let's look at the block diagram. First off, we know receive works. So let's go over here and see what happens in our receive. First off, if you look right here, it tells you transmit lines to follow, receive lines is the dash. So as you can see right here, this is our PA right here. Here's our drive to the PA. You can see it's got a solid line coming out to the antenna. We got our dashed lines here. So things are gonna kind of break off a little bit here and kind of branch off, and we got to just kind of follow out and see how we can go through this and figure out what's going on here. Some of this stuff is just going to be received. Some of it also works in transmit. So if we come in, we come over here and we go to the first RF amplifier. That makes sense. Now, if we follow the arrow, now we come to the first receive mixer, and as you can see, that just works in receive. Doesn't look like there's any transmit involved in that area. So this can't be the problem. We come in here and we go to our bandpass filter. Now let's take a look at a couple of things here. We got some solid lines going into this bandpass filter and receive. So this can't be the problem. If we've got AM going out, for one, this late in the stage, it's not going to be a problem. Two, we know this has to be working because we're getting our receive signals through it. We come through our second receive mixer. Come out of it, we go to our first IF amp. We also go to our noise blanker gate. This is all receive right here. This whole board is receive, so nothing on this board can be a problem. Let's see, we come back out. We're going to come out to our IF mixer, or on our IF unit. This is the MK10. This is right after the JFET that I was using, that I was testing before. This is this next one after it. So if we're receiving, it's not the one after it. Let's see here. We come out of here. We go through a filter, either sideband or CW. We come out. We got another IF amplifier. Another IF amplifier, which gets us to 3180. We come out of there. We either go to AM detection or we go to single sideband detection. Well, single sideband's a problem. Let's follow the single sideband path. It comes out. Oh, goes right the same place as the AM detection, but we're still on receive, so we know it's working. Preamp to the AF amp, out to the speaker. Okay, so none of those components we just ran through should be the problem. Let's follow our path going out. So we come in from the microphone. We go to the mic amp. We go to a secondary mic amp. We also have the Vox amp here. Now, I have tested that I can trigger the Vox. Well, if Vox comes in after the first mic amp, I know this is good. I know this one's good and the emitter follower are good. Why? Because AM works. I can get audio out of the AF unit, obviously, because at some point in time here, my AM is going all the way to the finals. There's a complete chain. So let's find out where we split on that. Where can we have AM work and single sideband not? We come out of the AF unit, which has got the microphone amplifiers in it. We come out and we go over to the modulation and oscillator unit. This is the unit that is mixing our first IF frequencies for AM to give us a carrier, our lower sideband, and our upper sideband. So we come in and our audio chain takes a kind of a chain, a split here, a fork in the road. If we come down from here and come down to here, we come to our AM oscillator, we inject our audio frequency, and then we got our buffer, AM modulator and CW buffer. So this is where our modulation's getting injected into our AM. And then it goes out, goes over, comes into the first mixer unit, Q1 on the mixer unit. So we know this is good. Everything here over has to be good because we get AM out. So where else does our audio frequency go? It also comes into the balanced modulator. And then comes out of the balanced modulator to MK10, which is the one that we were working on, the one that I thought was bad. Well, what else do we got coming into the balanced modulator? Let's follow this back down. And we go to the Q4, it's a buffer. And then we've got our upper side. Oh, what do we got here? We got sideband stuff going on here. We got upper sideband and lower sideband. Well, both of our sidebands are out. So, I'm thinking, statistically speaking, so to say, what do you think the chances that both of these are out? I don't think that's as likely as maybe a single component, but it's something we might have to check. But they do both come to the buffer. From the buffer, they go to the balanced modulator. Now, there's two ways we're not going to have single sideband transmission. Either one, we're not getting the audio into it to get it out, or B, we're not having the appropriate carrier frequencies generated and injected with the audio frequency to go to the first IF amp. This right here is taking the mixed signal between our audio frequency and our carrier frequency, a BFO frequency might be another way to look at it, to find out what it's going to do in order to amplify in order to send it to the IF unit. We know this should be good. Received's working on it. So just kind of following this logic, and if you actually look at the flowchart for troubleshooting, it says that if you have a single sideband problem and everything else works, it's got to be on the modulator and oscillator unit. But I don't think it's here. We have AM. I don't think it's right here, because if these two are out, well, let me stand corrected. These can't be out. You see that little dashed line right there? And this can't be out, the buffer, because it does have receive. This is where you start getting your, we have single sideband detection, and then this is where basically it serves as a BFO with either this oscillator if you're in a lower sideband or this oscillator if you're in upper sideband, in order to mix with it to have your, to see it comes over and it mixes with the SSB detector. This is operating as our BFO in order to demodulate the single sideband and send it to the preamp. So these have got to be good. We got upper sideband and we have lower sideband demodulation. This has to be good because it's still it's sending that BFO over to the SSB detector on the IF unit. So that really narrows it down, in my opinion, to being somewhere in here. Could this one still have a problem? Sure, I put the old one in, but it tested fine. From what I can gather, I can't find a data sheet on it. Just a generic test for a JFET, it passed. So we could have something wrong with our balanced modulator. We could have something with this signal isn't making it there. Upper sideband or lower sideband wouldn't work because they both got to go through here. There's only one of them used at a time, depending on what you're on. So right in here has to be our problem. Either this isn't getting injected into the balanced modulator, which means we don't have the carrier, and it's not going in there, or our audio signal is not making it through the balanced modulator. Let me see if I can find a, let's see here. So here's the JFET that I suspected to begin with. Here's our balanced modulator right here. right here is the buffer, which we know is good. So let's follow the output on this and see if we can get it over to, well, it might be easier to follow it this way. So we've got inputs here. And I have several inputs here. Let's see, pin 9 I believe is audio in. Okay, so audio in comes in on pin 9 right here. Comes over here. This is the AM mode. We know AM mode's working, so we know audio is getting at least to there. Then it comes over and it's injected into the balanced modulator. So we're either not getting our audio through here to be fed to the gate, or we're not getting our carriers, depending on which sideband we're on, injected in. So I'm thinking we either got some bad capacitors in here, it's possible, some bad diodes, maybe this is VR1. This is where you set your balance so that you don't have unwanted other signals. It keeps it balanced so you don't have the other side in there as well. So maybe we're not getting a good injection here. Let's see, we also have this to ground and these go to ground, so which would influence that through this inductor. So this inductor could maybe be bad. Maybe this variable cap is not set right. Or this transformer is not letting it pass, because as you can see, this is almost kind of basically separated as far as direct connection to the gate. It comes through here, the voltage is amplified, and then it's injected into that FET. So my first off checks, I would think, would be, could be here, not letting the carrier and audio mixed with it get to the gate. Might need to check this resistor. That would keep the audio coming from the mic amplifier from going in there. Maybe this one's burned out, went real high in value. I don't know if the diodes would be very likely, because when this radio worked, before it had an accident involving some line voltage and the antenna connector, which did blow the fuse lamp. So it's likely it protected everything, but I'm pretty sure that the radio was in receive when it did it. Obviously, otherwise we would have had a lot of other problems. In fact, I'm not really sure it would have ever made it past the tubes. I'm thinking this could still be a problem, not 100% ruled out. But I'm wondering if we got a problem right in here. We're either not getting to it, or it's not, either the carrier or the audio isn't getting through it. So I think the best way to test this is we're going to have to inject some audio into the radio, and a lot more than me just talking into a microphone or whistling into the microphone, because that's not a consistent input, and you know what, I run out of breath. I want something that's constant. So we need to just feed a tone into the microphone. And I don't have a signal tracer yet. I'm working on clobbering one together. I'm kind of seeing what design I want to use, and kind of seeing what parts I have. If y'all have noticed anything that I've built in the past on this channel, a lot of it I try to take what I have, see what I got in the old junk box, and put it together. So I'll have to take a look at what I got. So instead of a signal tracer, but I think we can just use the oscilloscope in the process. We won't be able to hear it, but we should be able to see signals on the screen, and we should be able to measure them at the same time. So I'm thinking what our next step is going to be is to actually start doing some voltage testing on this radio. We're going to start doing some signal tracing through it with the oscilloscope. We're going to inject some signals into it. I am going to have to build an attenuator. My signal generator does not go low enough. If you've noticed in the past, most of the time when I'm trying to feed a signal into the antenna jack, I usually use my tiny SA, and it goes to just below an S9 level input, which is microvolts. But it also doesn't, I don't think, go high enough to feed audio signals into a microphone. I'd have to check that, but I think I'd rather use my other signal generator. But I need to build an attenuator. It can almost go down low enough for audio signal levels into a microphone jack, but it's still a little hot, and when you start getting down that low, it doesn't have a nice undistorted output. So I'd rather feed it at a higher level, build an attenuator to bring it down to the right level. That way I know I have a good clean sine wave up at say the 1 volt range, and I'll build an attenuator that can bring it down to around the 10 millivolt range, and we can inject that into the radio. I still have to build that. I think I should have all the stuff to put that together. I'll probably start on that after I finish making this video. And we'll inject it, and we'll see just how far our audio signal is getting. Is it making it through the balanced modulator? What's coming out of the balanced modulator? Is it a good signal between the carrier and the audio mixed together? What's coming out of Q1? The FET that we're worried about. So we'll probably check that. We should be able to check and kind of see and know by either looking at the schematic, looking at service documentation, hey, on this pin, what should we have? I think we can find all that. So I think that's the way we're going to go. I know some of y'all are probably looking at it going, why didn't you just start voltages at to begin with? Because I didn't. When I first got the radio, we didn't even know it had a transmit problem. If it was just down on power. The original owner did not even know that the sideband was not working. So I didn't see the point in going through and checking all the voltages on the radio when we just had receive down was the main problem and needed to find out if it still transmitted. Well, we know we've got a problem now. And we thought, well, maybe Q1's right, until I did realize that MK10 does not have the same pinout, and I actually had to go look at another board to find out, hey, yeah, they just crossed the legs on this other one in order to make it. So that's our next step. We're going to take a look at the balance modulator, see if stuff's getting through that transformer, but I got to build some stuff first. I'm really going to like to build a signal tracer as well. But in the meantime, I'm going to build the attenuator for my signal generator, and make a little patch cord or something so I can plug it right in. Probably put a fancy little switch on it so I can key the radio. We'll run it into a dummy load, see what kind of voltages we're getting out. In fact, most of this right here, we could leave the heaters off and just see if the signal's getting through. I'm pretty confident we're fairly well okay on the final tubes. We did get 100 plus watts out on, I think it was 20 and 15. So I think they're strong. I think the radio needs some aligning because the bands aren't all consistent. 10 meters, we still got to figure out. It's at 2 watts output. Something's going on there. Might just be alignment. I don't know. We'll get to that. So we got a number of different things going on with this radio, but I'd really like to figure out the sideband problem. What good is a transceiver if it doesn't work sideband on HF or on ham radio? And then we'll clean that. We'll see if we can clean things up. I'm almost wondering if this radio might be in need of an electrolytic recap. Everything in there seems to be original. I did find one that did look a little suspicious. It's a 250 volt cap that might be bulging a little bit. It could just be the way it was built. I'm not sure, but that might be something that needs to be done on this radio too, is possibly a recap. So that laid that out. I hope that wasn't too confusing. Trust me, the path of going through looking for information, trying to find what FETs match other FETs, wholly, totally different pin outs on legs. I've had a fried brain trying to figure all this out and try to follow everything. But that's where we're at. We're going to get this thing figured out one way or the other, and just try to get this radio working. But this little sneaky little guy right here that decides it doesn't even want to have a data sheet in the web started some things, and then once I finally figured out the pinouts, it tested okay. I just almost wanted that thing to be bad. That would have been the easy way. Pop a new one in there, or find one that's close, and we're good to go. And I think that would solve what maybe would have solved the ALC problem. See, now if this is good, we still got the ALC problem. The ALC problem might be the problem. You know, if the ALC, of course, you would think it would bottom the meter in that case, but something's making the meter peg uncontrollable by VR2. So we got to figure that out too. So welcome to the craziness that's going on in the radio room. We're going to figure it out. But thanks for stopping by. I hope you followed through. I was trying to follow through in my mind, trying to figure everything out. But I was thinking of other things. Oh, you know, what about if this way? What about if that way? And about 14 things going on at the same time. But I just wanted to give you an idea, kind of maybe what we're looking at. And maybe where the problem is. Let me get my attenuator built. Let's get some audio into this thing. Let's get a signal in there that we can start doing some testing on. I can talk a lot, but not talk so much and consistently enough to test a radio. Speaking into the microphone, so we got to get a constant tone in there. So I'll go ahead and end this video here, and let me get to working on the attenuator and get the radio put back together to the point where we can do some testing, and we'll see if we can go from there. Thanks for stopping by. Hopefully you hung through the insanity of going back and forth. Hopefully it was more of a simpler path in my direction than what's going through my head right now. But thanks for stopping by, and we'll see you later.